Hello everyone. I forgot on Friday when we were talking that I wasn't going to be here Monday and Tuesday, so I thought I would go through the practice test and record it, and then I'll just put this on Canvas so when you get to school Monday, Mrs. Fennell's going to be your sub, and I'll just have her let you know that it's under the recordings tab. I'll put it under the recordings tab in the actual Canvas Calc course. I know we're not doing anything in Canvas. Everything's been in Florida, but you still are signed up for a Canvas class on calculus. So I will post it under a recordings tab on the home page of that course, and you should be able to find it there. Okay. So the first question says, use your graphing calculator to calculate or evaluate the limit as x goes to infinity of 1 plus x raised to the 4 over x. So you can go ahead and put this in Desmos if you want to. I'll do that real quick. And it's y equals 1 plus x raised to the 4x. 4 over x, I should say. Okay, so this is our graph, and if I zoom out, I can definitely see that it's going down to a number. The hardest part with questions like this, if you're using a graph, is you've got to go out so far to figure out what number it's approaching. And it would be real easy to say, is it approaching 0 eventually when it goes to infinity? Is it approaching 1? So a good way to it's good to visualize what this graph looks like. But looking at this problem, it might be easier to think about it by actually subbing infinity in for the x's. Okay? So if I look at the exponent, 4 divided by infinity, well, as the denominator gets bigger and bigger and bigger, the number is going to get smaller and smaller and smaller, and eventually it's going to be approaching 0. So if we look at 1 plus x raised to the 0, or even 1 plus infinity raised to the 0, remember any number raised to the 0 is always 1. So the graph, if I went out far enough to the right, I would see it eventually approaching 1. But algebraically, just substituting it in and understanding what infinity in the denominator does means that that number in the exponent is going to 0, which means the function's going to 1. So the answer here was 1. Okay, let's see if I can get my board to work here. Next question. Use your calculator to select the best answer below. 10 to the x divided by negative e to the x. Well, this is also 10 to the x times negative e to the negative x, if you do it that way. Or I could even, if it's got the same exponent, well, let's just look at it. The calculator for me, when I put it in, it didn't really help. So I did more of a logic idea here. If I put in 1, say I put in 1 for x. So it's 10 to the 1 divided by negative e. So that's going to be a number, and it's going to be a negative number. If I put in 2, now I've got a positive number, right? And it's going to be a little bigger. The number is going to gradually get bigger and bigger because 10 to the x is bigger than e to the x. 10 to the x is, well, e is, remember, is about 2.7. So the numerator is going to be bigger. It's going to be bigger positive and bigger negative as it goes. So as it's going to positive infinity, which this one is asking for positive, isn't it? It's hard to read. I think so. Positive infinity. As it goes to positive infinity, this number on top is going to be, you're going to see part of the graph going up, and then it goes down, and then it goes up, and then it goes down. And the separation between the two is going to be bigger and bigger and bigger and bigger as it goes. So if I said positive infinity or even negative infinity, it's not really going to approach either one. It's just oscillating between bigger and bigger numbers as it goes negative and positive. So this limit does not exist. So that one I didn't really graph, but just tried to logic through it. Okay, next one. Limit as x goes to a of x minus a over the square root of x minus the square root of a. Anytime you see roots like this, always think about conjugates, using conjugates. So I'll pull up my whiteboard here. So I have x minus a over the square root of x minus the square root of a. And just to refresh my memory, x is going to a. The limit as x goes to a. Well, always try substitution first, because if you can do substitution and actually get a number, you never have to mess with doing any other algebra processes first. But of course, when we put a in, we get a minus a is 0, and the square root of a minus the square root of a is 0. So 0 over 0, we know we have to do something else here. So this is where the conjugate comes in. I'm going to multiply by, I don't want to make that quite so big, the conjugate. And now I'm not going to distribute the numerator. I'm just going to leave it. But I am going to go ahead and FOIL this. And if you recognize this, this is just the difference of two squares. So all I have to do is square the first term, which is x, and then square the next term, which is a. Well, what do you know? This cancels with this. And I'm left with the limit. You always should keep writing this limit in front. If you were actually taking a college calc class, they would dock you points if you didn't keep writing limit as x goes to a of the square root of x plus the square root of a. Now I can substitute a in for x, and I have the square root of x, square root of a plus the square root of a, which equals 2 square roots of a. Let's see if that was an answer. That's always helpful. Yes, 2 square roots of a. Okay, next one. Find the limit as x goes to 0. Of 3x plus 1 minus cosine squared x over sine x. And x goes to 0. So let's plug in. We have 0 plus 1. Cosine of 0 is 1. So 1 and 1 squared is 1. So 1 minus 1 is 0. So I have 0 in the numerator, 0 in the denominator. Not going to work. But I could separate this. 3x plus could do that, because 1 minus cosine squared is just sine squared. Now, be careful. I can't just cancel here. And is it 3x plus or just 3x times? It's 3x plus. So I can't cancel here. This is the same thing as 3x over sine x plus sine x. So now I still don't have, I still have 0 over 0. This is actually 0 when I plug in 0. And I should keep writing the limit. So I'm thinking, if I plug in, I still get 0 over 0 plus 0. So is there something else that I could do here? I was just going to see, I can't factor anything. You can tell I haven't looked at these before I actually made this video, so I'm trying to decide if I call it undefined, because we can't simplify this any further. Let's see what the choices are. Does not exist, 4, 3, or 0. I wonder if we graph it. Limit as x goes to 0. Let's just see if it actually approaches a number from both sides of 0. See if my algebra process didn't work very well. Okay. Limit as, well, I'm not going to put a limit in here. 3x plus 1 minus cosine squared x. And then I put this parenthesis, and I do divided by sine x. Ooh. As x goes to 0, from the right and the left, it definitely looks like it's approaching a number right in here. I don't know. it either doesn't exist there or it actually approaches a number. Let's see. As I get to 0, look at that. As I graph it, it does say it's undefined at 0. Okay, so that the limit is approaching what number? If I look at this, it's getting closer and closer to what? 0.1, so there's 3, 3.4, 3.3, then it's undefined, and then it comes back and it's approaching, it looks like it's approaching 3. So graphically, I could say it's 3. I'm just trying to figure out what I would have done differently algebraically to prove that, because I definitely don't get 3 here. What I could do is, well, it's approaching 0. You don't know derivatives yet, so I can't show it that way. I would just have used the graphic method that way on that problem. Okay, next problem. And let me pull it up. Maybe when I get back, you guys can show me if you did it a different way to actually prove it's 3 algebraically. Okay, next problem. If the limit as x approaches 0 of f of x is -1, and the limit as g of x approaches, or x approaches 0, of g of x is 1, then find the limit of f of x plus g of x squared. Well, the limit of f of x is -1, the limit of g of x is 1, so when I add those two limits, it's just 0 squared, which is 0. Okay. Evaluate the limit of the absolute value of x minus 1 divided by x minus 1 as x approaches 1. So I'm going to go ahead and graph this one. Okay, and this is as x approaches 1. So as x approaches 1 from the right, it looks like it's approaching, the y value is 1. As x approaches from the left, it's -1. Since the limit from the right is +1 and the limit from the left is -1, this limit does not exist. It has to be the same value from both the right and the left. Okay, next, evaluate the limit as x goes to 5 of 1 over x minus 1/5 divided by x minus 5. And this is the limit as x goes to 5. That's really messy. Okay, first thing we're going to do is get a common denominator in the numerator, which is 5x minus x, 5 minus x over 5x over x minus 5. Well, the numerator and the denominator aren't the same, but I can do something to either one so they would be identical, and that is to pull out a -1. So let's pull out a -1 out of the numerator. And remember, if I'm dividing by x minus 5, it's the same as multiplying by the reciprocal. Okay, so now I can cancel these out, and I'm left with -1 over 5x. And then this is as x approaches 5, so this becomes -1 over 25. Which is, yeah, this one here. Okay. Limit of 5x, of sine 5x over 6x. And there's a strategy using derivatives, so I know it's 5/6. But trying to tell you that when you're in the early phases, let's graph it and see. Sine 5x over 6x. And we want to zoom in on this. And this is as x approaches what? Oh, it's in the right. Hold on. As x approaches 0. Okay. So I can see it's definitely getting closer and closer to some number. And the best choice here would be to figure out, well, it's 0.833 is what it's approaching. And if I look at my choices, 5/6 is 0.833. You'll learn another way to do this later in calculus. But let me find, at this point, what I would have done probably is look at my choices. It definitely exists because it's approaching a number. 1, it's actually at 0, it's 0.833. So 5/6 is the answer. If f is a continuous function with odd symmetry, what does that mean, odd symmetry? Continuous function means, and it has odd symmetry. If it's odd, it's symmetric around the origin. So the easiest example of odd symmetry is the line y equals x. Okay, but another one you could do is y equals x cubed, and so on. But those have odd symmetry, and it's continuous, so that's what it's saying. And as x goes to infinity, f of x is going to -5. Which of the following statements must be true? As x goes to infinity, y approaches -5. It's got odd symmetry. So I know when I go back to my graph, what it's really doing, because it's odd, it's got to be a negative slope. So it's approaching -5 as x gets bigger. So if we call this -5, and as x is getting bigger and bigger and bigger, it's going to be approaching there. And if it's symmetrical, maybe it's going to do something like this. I'm just kind of sketching as I go. Which of the following statements must be true? The limit as x approaches, I can't read it on the starboard, so I have to look here. The limit as x approaches infinity of f of x has to equal 5. No. If it's symmetrical around the origin, it's not going to be like a, if they're both equal to 5 as it goes right and left, that's going to be symmetric around the y-axis, which is an even function, not an odd. There are no vertical asymptotes. Well, we don't know that just because the limit exists, because it could be approaching -5. I'm trying to think here. If it's a vertical asymptote and it approaches an actual number, let's think about what that means. Let's draw a function that has a vertical asymptote. So it could go up like this, and it could go down like this and still be odd. Okay, so as it approaches -5, well, -5 could be in here. So it could still have a vertical asymptote, even if it approaches that. That's not the right place, -5. Let's just say 1, 2, 3, 4, 5. So here, if it approaches from the left and the right, it could still approach -5 and have a vertical asymptote. So just because it has a fixed number doesn't mean it can't have a vertical asymptote, but it also means it could. So I don't think you could say that there are no vertical asymptotes. The lines y equals 5 and y equals -5 are horizontal asymptotes. So as it goes to infinity, it's approaching -5. So I would say that's the answer, because if it's approaching -5, as it gets bigger and bigger and bigger to infinity, I'm thinking it's going to be more like the graph I drew before. Now my board's not going to work. I'm trying to go up. this graph here, where as it's odd and it gets bigger and bigger, this one's going to negative infinity, which means if it's odd, this has to be going to positive infinity. So you definitely would have a horizontal asymptote here as it's approaching and one there. So my answer on this one is going to be 3 only. Okay, what are the horizontal asymptotes of this function? 2 times the square root of x squared plus 4 over x. Well, a horizontal asymptote, to find your horizontal asymptotes back from pre-calculus when we learned this, you take the degree on top over the degree on bottom. And the degree on top, so if I look at this, it's the square root of x squared. That's really the degree. Well, the square root of x squared is plus or minus x. Plus or minus x. And when I have that divided by x, then that's going to be 2 times positive x over x, which is just 2, or 2 times negative x over x, which is negative 2. So I think my first inclination is going to be that we're going to have a horizontal asymptote at both 2 and negative 2. But the best way to check this is just to graph it. So y equals 2 square root of x squared plus 4 divided by x. Okay, so there it is. Now we're seeing the horizontal to the right is going to be positive 2. We also have a negative 2 asymptote. Y equals negative 2. So it's this one. Which one or ones of the following statement is or are true? If the line y equals 2 is a horizontal asymptote, then f is not defined at y equals 2. Well, that's true. If it's a horizontal asymptote, it will never reach 2. It will always, it's not defined there. The limit actually exists there, but it's not defined there. So 1 is true. If f of 1 is greater than 0, and f of 3 is less than 0, then there exists a number between 1 and 3 such that f of c equals 0. This is called the intermediate value theorem. And I've lost my pen. Intermediate value theorem. So if f of 1 is greater than 0, so that just means if I have 1, it's going to be some number, y will be greater than 0. And f of 3 is negative, which means 1, 2, 3. Okay, so it's going to be somewhere in this range. It doesn't have to be this point or this point, but it's definitely positive here, negative here. Then there exists a number c between 1 and 3 that f of c is 0. Well, that's true, because in order for it to go from this number to this number, it's got to cross the x-axis. And that means y is equal to 0 at some point between 1 and 3. We don't know exactly because they didn't give us the function, but we definitely know it crosses the x-axis there. So 2 is true. 1 is true. 2 is true. My only choices are 1, 2, and 3 only, or all statements. And since 1 and 2 are true, I'm going to say that all statements must be true, but let's look. If f is continuous at x equals 6, and f of 6 is 8, and f of 4 is 2, then the limit as x approaches 2 of this function has to be 8. If the f of x is continuous at x equals 6, okay, so there's some function, 1, 2, 3, 4, 5, 6, and it's continuous, and it actually equals 8 at that point. So f of 6 is 1, 2, 3, 4, 5, 6, 7, 8. F of 4 is 2. 1, 2, 3, 4, 2. It's continuous at x equals 6. F of 4 is 2. The limit as f of this new function, fx squared minus 10, must also equal 8. So that's f, is 4x squared minus 10 as x approaches 2. x approaches 2 must also equal 8. So if I put 2 in, 4 times 4 is 16, minus 10 is 4. X approaches 2, I don't see that that's equal to 8. F of 4 is 2, f of 6 is 8. I don't know. I'm struggling with number 3. I don't know. I would still answer all statements are true. I'm not able to prove that one very clearly for you, but I believe 1 is true. If the line y equals 2 is a horizontal asymptote of the function, then f is not defined at y equals 2. Well, that one's questionable too, because I don't know if you remember, you can't have a point exist on a vertical asymptote, but it has happened where lines cross a horizontal asymptote. So that function could actually exist. I don't know. I might just answer 2 only here. We'll see how I do. I don't know if I've answered the rest of these as I've gone, so we'll have to, this is 5, 6. I'll have to grade my test at the end. This is 3. And this one does not exist. And then this one was 1. Okay. Are we getting close? Okay. Find the limit of x cubed plus 9x squared plus 7x divided by 3x squared minus 4x plus 1. Okay, so I'm going to factor an x out. I'm just going to work on simplifying this, and then I'll take the limit at the end. So x squared plus 9x plus 7 over 3x squared minus 4x plus 1. Well, that factors to x, can't really do anything, can I? Plus 9x squared plus 7. What's the denominator factor to? Maybe I just need to try and test it by plugging in. Oh, it's to infinity. Okay, so when we look at infinity and we plug in, as it's going to infinity, it's going to be approaching a horizontal asymptote. So this is where your rules, forget the factoring, this is where your rules of how to find a horizontal asymptote will really come in handy. If the degree are the same, remember the horizontal asymptote is going to be the ratio of the top over the bottom, the coefficients. If the degree on top is bigger, like this one, than the degree on bottom, there is no horizontal asymptote. Okay, and then if the degree on bottom is bigger than the degree on top, the horizontal asymptote equals 0. So here, because there is no horizontal asymptote, and this is going to be a positive number as it gets bigger and bigger, the answer is infinity. It's as it goes to the right more and more, this function is going bigger and bigger and bigger, and we could look at the graph and see. But that's how you do it algebraically. You look at where there might be a horizontal asymptote, and then that horizontal asymptote becomes the number it approaches as it gets bigger and bigger. Because there's no horizontal asymptote here, there's only an oblique, this number is going to increase without bounds. Okay, the next is evaluate the limit x as x approaches 2 from the left of x over x squared minus 4. Well, if I put in 2, it doesn't work. What happens if I go ahead and just do a radical times it? Let's see, x over x squared minus 4. If I multiply top and bottom, I don't know if this is going to help. I get, what, x squared minus 4 and x times the square root of x squared minus 4. Did that help me at all? Because I'm still using the limit as x approaches 4, right? No, it's from 2. It's still 0 over 0. So that didn't help. So let's just look at this graph. X divided by the square root of x squared minus 4. X divided by square root of x squared minus 4. And I want to know as x approaches 4 from the right. As x approaches 4 from the right, no, 2 from the right, sorry. As it approaches 2 from the right, it's shooting up to positive infinity. So that's my answer. 2 from the left. 2 from the left, it looks like it's going to negative infinity. Is that right? No. Yeah. Negative infinity as it approaches 2 from the left. So I don't agree with any of these three. I really don't. It doesn't exist, but that's not the limit from as it approaches 2 from the left. The limit doesn't exist as it approaches 2 generally. Oh, let's do 2 from the. It's not negative 2. It's approaching 2 from the left. Well, I can't approach it from the left. That's the problem. I approach from the left. It does not exist. There's no way to get there from the left. So that's my answer. Which of the following are the equations of all horizontal and vertical asymptotes for this graph? Well, x is a whole, so that's not an asymptote. 1 over x squared minus 4, so I'm going to have a plus or minus 2. Plus or minus 2 are my horizontal, are my vertical. X equals 2, x equals negative 2. There shouldn't be a whole. I mean, there shouldn't be a 1 at x here at 0. That's not going to be an answer. So it's not this one, and it's not this one. So I'm down to these two. And I want the horizontal asymptote. Well, the degree on top is less than the degree on bottom, which tells me the horizontal asymptote happens at y equals 0. So it's this one here. How many more do we have? Okay. Evaluate the limit as x approaches 2, this function. So the only way it's going to exist is if it approaches the same number from one side to the other. So if x is less than 2, so as it's coming in from the left, if I put 2 in, 4 minus 1 is 3. The actual point is 1, but that's okay. If this side is approaching 3, then I know that the limit exists. So when I put it in for here, 2 plus 6 is 8, so it definitely doesn't exist. It has to be the same number from both sides. Where is this function discontinuous? So we would factor this, x minus 4, x plus 2. So at negative 2, there's going to be a discontinuity. It's a whole, but it's still a discontinuity. And it was x minus 4, so it's going to be at 4. It's discontinuous at x equals negative 2 and 4. It's a whole at negative 2, and it's a vertical asymptote of 4. Which of the following are continuous for all real values of x? Well, I know this is going to have a vertical asymptote, so that's not continuous. This is continuous because I could draw the v without picking up my pencil, so that one works. This one, there is no asymptote. The degree on top is less. There's no vertical asymptote here because x squared can't equal negative 1. So let's just try that one. 3 divided by x squared plus 1. And it exists. I think that one's continuous as well. So I would say 2 and 3 only. This one definitely is not continuous. Which of the following must be true for the graph of this function? So we have x minus 5x plus 5, and 5 times x minus 5. So at 5, there's a removable discontinuity, so that's true. And at negative 5, there's a vertical asymptote. There's not a vertical asymptote at x equals 5. So A is true, and I think it's just one only. X plus 5, x minus 5, and then you have 5 times x minus 5. So the 5 cancels. That's removable. It's not an asymptote, and it's not an infinite, so that would be it. This one, average rate of change, so you're just going to plug in, it's really the slope. I mean, average rate of change is the slope of the the line, especially if it's a line. It's when it's not a line that it gets really difficult to find the slope. That's why derivatives, or using the long way to find a derivative using limits, comes in handy. Instantaneous slope at -2 over x. So the first thing I've got to do is the limit as h goes to 0 minus -2, so that's plus. Okay, get a common denominator. This cancels. This cancels. This is the limit as h goes to 0. So I'm left with 2 divided by x times x plus h. Which is equal to 2 divided by x squared. Okay, now I'm going to plug in the value. I think it was 3. Yes. And I know that this is then equal to 2 over 9. The height s, so this is another one I'm just going to be substituting in x plus h to find the instantaneous velocity. When it hits the ground, that's when x equals, y equals 0. So I'm going to take the derivative, or find the limit as, let's just do it, -16t squared minus 32t plus 48. Okay, so let's do the t plus h squared minus 32t plus h plus 48 minus -16t squared minus 32t plus 48 all over h. So this ends up being -16. I'm going to do this 2 steps here in one, because this is t squared plus 2th, so that's minus 32th plus minus 16h squared minus 32t minus 32h plus 48 minus plus 16t squared plus 32t minus 48. So my 48 cancels, my 32t cancels, my 16t squared cancels. All I have left are things with h's in them. This is an h. All right? Yeah. Minus 32h all over h. So that cancels with this, and I'm left with one of these. So this ends up being -32t minus 32 when I take it to 0. Okay, so that's the derivative. That's the instantaneous slope. And it wants to know this when it hits the ground. So just imagine this parabola. I don't know exactly what the parabola shape is, but I do know it's going to be going down because it's negative leading degree or leading coefficient. At this point, it hits the ground. So I'm going to set 32t minus 32 equal to 0. -32t equals 32. Is that right? So t is equal to -1. Is that a choice? No. Can't have a negative time. S of a ball thrown straight down with initial speed of 32 feet per second from a cliff 48 feet high. That's its position. T. What's the time elapsed that the ball is in the air? Or t is the time elapsed that the ball is in the air. How do I get -1 when I do this? The instantaneous velocity is definitely -32t minus 32. And the velocity when the position is 0 So do I need to make a so negative 32 is its acceleration. The height s of a ball thrown straight down. So it starts at 48 and then it goes down. What is the time elapsed that the ball is in the air? Or where t is the time elapsed. What's the instantaneous velocity of the ball when it hits the ground? I've done something wrong here. I solve for t, and I plug that back in, maybe? At 0, time is equal to -1. Then I plug that back into the velocity. So I get negative 32 times -1 minus 32 to get 32 minus 32 or 0. And that doesn't seem right either. Negative 16t squared minus 32t plus 48, where t is the time elapsed that the ball is in the air. What's the instantaneous velocity of the ball when it hits the ground? So how fast was it going? I don't know. Did something wrong, or I'm not following. So this is its velocity, instantaneous at t. And I want to know where that's the velocity is 0. This is the instantaneous velocity is negative 32t minus 32. Well, its velocity when it hits the ground is 0. Or do I go back and find if this is its position? I set this equal to 0, find the time, and then plug that in for, that's probably what I do. Okay, so if I factor out a negative 16, I get t squared plus 32, or plus 2t plus 3, minus 3. So this factors to negative 16 times t plus 3, t minus 1. So I know it's going to happen at negative 3 or positive 1 when the distance is 0, or when the y value, the position, that's the position, is y equals 0. Yeah, that's right. Okay, so now I'm going to plug 1 in to what I found to be my velocity. When I plug 1 in, I get negative 32 minus 32, negative 64. Final answer. You can see that I didn't go through these before I start answering, but I think that's it. Okay. The surface area of a right cylinder of height 4 and radius r is given by that function. Find the instantaneous rate of change of the surface area with respect to the radius when r is 4. Okay. So this is 2 pi rh, 2 pi r squared. And this is the surface area. So I've got to do 2 pi r, I've put in h, I've got to do something different. I'm going to use, that's height. So let's use let's use y here or something. It's h times y plus 2 pi r plus h squared minus 2 pi ry plus 2 pi r squared. So those h's will get too confusing here if I go to h. And this is the limit as h goes to 0. So it's 2 pi times r plus 2 pi, I should say 2 pi y r plus 2 pi y h plus 2 pi times r squared is 2 pi r squared 2 plus 4 pi RH plus 2 pi r squared minus 2 pi ry plus 2 pi r squared. So that cancels. Well, this whole thing needs to be here, so this is negative. That cancels with this, and I have 2 pi ry, which is this, cancels with this. So everything should just have an h in it. Two pi squared, 2 pi r squared. Did that cancel with anything? I've really confused myself now. Minus 2 pi r squared. So I have two 2 pi r's. 2 pi ry, 2 pi r, 2 pi hy, that's that. 2 pi times r squared plus 4 pi r plus 2 pi, this should be, that's my problem, 2 pi h squared. Okay, so the 2 pi r squared cancels with this one. Sorry about that. 2 pi hy plus 4 pi rh plus 2 pi h squared. And everything else is, I can't go anymore, is gone. Okay, this is all over h. And then one of these is gone. And as it goes to 0 then, if I take the limit, as h goes to 0, this goes away, and I'm just left with 2 pi y plus 4 pi r. And remember, at the beginning, I substituted y for h. Okay. Yeah. So let's see what the question says now. Find the instantaneous rate of change of the surface area with respect to the radius. And the height is 4. There's that. The height is 4. So 4 and 4. So I put 4 in here. 2 pi times 4 plus 4 pi times 4 is 8 pi plus 16 pi is 24 pi. So that's that. Okay, let's see how I did. Submit. Where do I see my grade here? 5, 6. Aha. It was all statements are true there. If f of x if f is a continuous function with odd symmetry, there are no vertical asymptotes. So I don't think that can be. I'll have to look at that one again. And I missed that one too. What did I say? Which one or ones of the following statements is true? Yeah, I don't understand that one either. We'll have to talk about those two. How did I do on the rest? Okay, well, wasn't perfect, but 2 of them I need to think about a little more, and then we can talk when I get back. Hopefully this helped. You can see that even the teacher can't get 100 on these, so you're doing pretty well when you just pass them. I will see you Wednesday. Talk to you later.